And the component for P2 is called X2 and Y2. Conclusion, P1 is a point that is represented by the component X1, Y1, and P2 is the another point is represented by the component X2, Y2. So we connecting P1, P2 by the segment line. And the distance is the length of this segment, no? So you can compare, for example, this segment. Okay, actually, we have a triangle here. Okay, this segment is x2 minus x1, and vertical is y2 minus y1. It doesn't matter what you're subtracting, what you addition, because basic is the distance, and distance is absolute value. You can compute actual value, but the hypotenuse of this triangle is the distance, is square this let, and take out square root everything, and this is the distance. Okay, this is my first formula que we studied, distance formula. Now, midpoint. Well, midpoint is the point in the middle here. This is midpoint, capital M, midpoint. And the formula for the midpoint is super easy because it's like an average. For example, midpoint have also two components, no? Midpoint have also two components. Let me call x sub m and y sub m. And the formula to compute x sub m is the average. It's x2 or x1, whatever. One first. x1 plus x2, doesn't matter the order because it's addition divided by 2, and y sub m is exactly the same. It's pero using the y component, y1 plus y2 over 2. And this is the formula to midpoint. Okay, and this is the formula for the distance that we are using throughout the class. Okay, easy, the proof. Now example, elementary example. Example easy. Suppose that we have 2 points. It's given. P1 is -4,0, and P2 is 4,6. And they want, okay, you find distance in between the point, so distance, we find this D, and you find the midpoint, location. Okay, number 1 step is plot the point on the rectangular coordinate system. The first point is -4,0, -1, 2, 3, 4 here. I plot that P1. This is P1. And P2 is 4,6. 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, and 6 here. This is P2. Okay, I need to find the distance. And by the way, the midpoint. This is my goal. Okay. Let me try to apply the formula and also, why not, interpretation the idea. Look, remember the distance is a big formula. However, it's super easy to determine, for example, what is the distance between -4 and +4? What is the distance between -4? So in other words, what is the length for this segment? It's obvious it's A, no? So you apply the formula says square root, and you're subtracting the x component. It doesn't matter the order. Suppose 4 minus -4, no? Because the formula have that minus. However, the component for the P1 is -4. Look at that, x1. Entonces, actually, it's 8. The answer to this is 8 because double minus become positive, and you see clear in the image in the rectangular coordinate system. The distance in the horizontal part is 8. And now this is a square. Okay, by the way, is 64. Okay, this is the idea for the x part, and the y part is easier because it's that distance, and by coincidence or curiosity or something, the y component in the p1 is 0. So the only que have value is the y2. This is y2, this is y1. Entonces, when you subtract, suppose que you don't understand very well the geometry idea. However, you subtract and apply the formula. Directly, the formula is 6 minus 0, que es 6 squared, que 36. Okay? And this is 100. And square root 100 step. So, in other words, this distance, este, is the length of this. Okay, linear unit, because it's distance, maybe it's a meter, inch, meter, mile, depending the application. Okay, now let's compute the midpoint. The midpoint is easier. Midpoint, using my intuition, look like here, approximate, right? This is midpoint. This is midpoint. However, well, okay, I don't care. I apply the formula. The formula says that x midpoint is you adding the component in x. This is x1 and this is x2, no? Entonces minus 4 plus 4 divided by 2 is obvious que es 0. And y1, ym, sorry, is the same idea, but on the y component is 6 plus 0 divided by 2 is 3. Therefore, the conclusion is the midpoint is located at the position 0,3, que is exactly we predict here, 0,3. Any question, guys? No? No. Okay, super. Now let's move on to the first application of the distance formula, que is a circle. A circle. Okay. Circle is a geometry plane. Definition is a set of the point. This is the set of the point definition. Set of the point. Of course, in the XY plane, that are a fixed distance Okay, by the way, normally this fixed distance is called radial. Normally it's denoted by letter R, the variable that we're using for this, from a fixed point. A fixed point is a center. And the variable that we use it to denote the center is h, k. Center is the point. And the point has two components, no? The x component and the y component. Normally, in this part of the mathematics, the terminology that frequently using is the x component is h and the y component is k. Okay? In other words, we have one point, h, k. we have one fixed distance, que es el radio. And this determines one point, x, y. But it's the only point? No. We have infinity point that satisfy this. Okay? So that circle is the set of the point. Set of the point. Okay, this point, this point, this point. Que satisfy this. Okay, entonces now, si I want to find the equation for the circle, it's super easy because you apply one more time the distance formula. Distance formula is equal to square root x2 minus x1 squared plus y2 minus y1 squared. And the distance in this case r is the radio. Entonces I suppose que x2 is completely arbitrary value on the circle. Okay, denote en general x, y. Entonces x minus the x component for the center, que es h square, plus y minus k square. Now, to make a little bit more elegant equation, you square both sides, square both sides, square both sides, and you have r squared is equal x minus h squared plus y minus k squared. Wow, and this is the famous formula of the circle. This is the famous formula of the circle. Okay, express it. Okay, what's the name of this formula? It's equation of the circle. It's equation of the circle in standard form. Okay, this is not the only equation for the circle you have available. We have more, but this is the most important, standard. Okay. Suppose one elementary example. Suppose one elementary example. Suppose that we have an example of the circle. Suppose that we have write the standard. Okay, write. You need to write. Form. Of the equation of the circle, of the equation of the one hypothetical circle with the radius is equal 4 and a center the point 2, -4. Okay, this is the information. So in the circle we need two pieces of information. We need the radius. Okay, repeat again, is the distance between the center to any point on the circle and the center. Okay, is the most important point. I know, I studied that the formula is x minus h squared plus y minus k squared equal r squared. And this is the center. Okay, and the center, this component is h and this component is k. So the x component is 2. So my equation is x minus 2 squared plus, and k is -4. But we have the important idea that the equation have a minus here and the k value is negative. So we have double negative when you plug it in, no? This is positive. Be careful. This is the most common mistake of the student. The sign and the center point is completely opposite to the h and k in the equation because the equation have the negative in the front. And that's it. And we have 4 squared, and 4 squared, r is 4, r, little r is 4, therefore r squared is 16. And this is my equation. End the story. Okay. If you want, you can put in decimal and you see the circle. But no, not necessary now. Any question, guys? Everyone follow me? Okay. Let's move on to the example 2. Example 2 is a little bit more complicated because the equation of the circle is given non-standard. So it's given one equation. So one graph. So I want to graph the equation. The equation gets given by like that: x squared plus y squared plus 4x minus 6y plus 12 equal to 0. Okay, in this case, the equation is a circle also. How do you know it's a circle? Because the formula involves square, quadratic, and linear. Entonces, this is a circle. Of course, we have some translation, the shift, horizontal, vertical, depende, I don't know exactly, but it's a circle. Now, the problem is that the equation is not expressing a standard. No. Entonces, you don't see clear. It's not clear. Totally confusing. What is the center? What is the radius? Entonces, the technique we use to determine this is conversion. This is the general form. Is the technical name. General form. Convert to a standard. So the technique is always the same. You're using complete square. So you bring down x squared. You group in the x. Look, x and x together. And you put a box. Inside the box, we have the magic number that completes the square of this trinomial. And you group in now the y part. The y part is y squared minus 6y plus another box, because we need to complete the trinomial and the x part in the y part. Now this 12 I move to the right hand side like a minus 12 plus 2 boxes, because when I introduce artificially the number que complete the square here in this box, question mark, I need to put in the other side in order to keep the equilibrium for the equation. Okay, and let me recall how we complete the square. The complete square is easy, and the equation is normally a x squared. Oh no, a. Suppose que the coefficient is 1. Suppose x squared plus bx plus c. The completed square, actually is not c, is one value, no? I need to find, is b over 2 squared. This is the formula. Or b squared divided by 4, que is the same. Now you take 4 in the first case, divided by 2 and square. 4 divided by 2 is 2, 2 squared is 4, and the magic number is 4. And for sure, the factorization of this trinomial is x plus 2 squared, because I guarantee introduce this number, que this trinomial is perfect square, and the factorization is formed by two factors totally identical, twin brothers. And the second is 6 divided by 2, que is 3 squared 9. When you introduce 9 here, of course, this trinomial is perfect square. This plus is this plus. I just bring down y minus the sign in between is the first sign, 3 squared. In the right hand side, well, we have 4 and 9. And 4 plus 9 is 13 minus 12 is 1. Wow. And this is my equation. My equation is x plus 2 squared. Plus parenthesis y minus 3 squared equal 1. Okay, so in this case, center of this circle is located at the point minus 2, 3. Remember, completely opposite sign. And the radius is, well, square root 1. Because this is r squared, therefore r squared equal 1, therefore r alone is 1. Okay, this is a standard form. Okay, the standard form is super easy to see clear. Where is located the center and where is the radius. And curiosity, let's do the graph of this equation in decimals. So I propose you do the graph first of all of the original. After we plot the center and you see the radius, and after I propose you do the graph of the standard and you see si es the same or no, si es equivalent or no. I don't know, I suppose que yes. Okay, entonces I switch into decimals. Let me try. Okay, decimals I have with new. Okay, new graphic, completely blank. Okay, let me share the screen to decimals. Good. I suppose you see decimals now, right? Yes or no? Good, good, Yasmin. Okay, Yasmin. Entonces now I propose you put the original equation is x squared plus y squared plus 4x minus 6y plus 12 equal 0. Bam! I have a circle. Okay, I realize, so I discover that the center is located at the point -2, +3. -2, 3. Bam! This is center. And the radius is obvious. Look at that, the distance between, for example, looking horizontally from -2 to, so that point is -1,3. Let me try. Comma, separated by comma. Okay, separated by comma. I know the radius is 1. Entonces, suppose this point is -1,3. -1,3. Bam. I have another point case maybe -3 and +3 in the left direction. -3, +3. Bam. Okay, comma. Walking up and down. Entonces -2,4 because the component H is -2. Okay, good. However, when you walking up 1 unit gets a radius, es obvio que 4, +4. Bam. And finally, the last point is down, is subtraction, the y component. So it's a -2, +2. Okay, I like that. -2, +2. Everyone follow me? Do you understand what you're doing or no? Or you are totally lost? The radius 1. Okay, I understand. Okay, Yasmin always understand. Okay, Yasmin, now to verification that everything is okay, that we're doing well, I propose you put the equation of the circle, that the same circle, but in standard. In standard was, parentheses, x plus 2 square, wow, plus parentheses y minus 3, okay, square again, equal 1, because the radius in this case 1, equal 1. Bam! And now you see in green color, que is perfect coincidence, both set of the point or geometric place. Suppose que I put on enable the standard, que es green, and you see the red. Okay, now the green or the red, whatever you prefer, or the combination. Any question? Any question? Any question? Any question? Piece okay or piece of rock? Super easy or super complicated? Okay, let me go. Easy, piece okay. I understand, Sean. Okay. Let me see, share screen to whiteboard. Okay. Now I try to explain another thing. More complicated, more interesting. Okay. Whiteboard? Do you see whiteboard? Okay. Okay, no. We are discussing, yes. We are discussing now a family of the curve que is called conic sections. Conic sections. Okay, conic sections, en plural, conic sections. The conic section is a family of the important. It's important because you are using in calculus. In another subject, like physics. It's a family of the curve que derive from the conic. Basically, we studied one of the three most important: ellipse, number 2, parabola, and that order we are studying parabola. Well, actually, the parabola we discussed before. However, you see a more general way. And number 3, hyperbola. Okay, and this curve is different. It's coming from the same idea, conic section. I want to explain now. For explain this idea, I create in GeoGebra. I create one interesting script. Okay, let me see. Let me share with you GeoGebra script. Bang. Do you see GeoGebra? Okay. Remember, you don't worry for the 3-dimensional figure, because this is a topic we studied the student can need to take calculus 3. However, sometimes it's necessary to explain something, no? Okay, this part is not important for you now. The important for you now is understand the conic section and how the conic section is coming from the double cone. You see here in that moment our axis. The red one is X, the green one is Y, and the blue is Z. 3-dimension. And this is the equation for the double cone. So I intersecting the double cone using different planes. This is my first plane. Bang. Look, this is my first plane. Intersecting the cone, form one specific curve in pink color. Let me to see clear. Let me remove the plane and remove the double cone. And this is the ellipse. The ellipse in 3D or in 2D, that doesn't matter, is the intersection, the double cone, and the plane. And the important thing is that one specific angle, because the cone have your own angle. See, the angle of the intersection is less than the angle of the cone is from ellipse. And ellipse, you see, is is a closed figure, like a circle, but actually it's not circle because the dimension in one direction is not necessarily equal in the other direction. I want to explain in detail this idea in your moment. No, now. Okay, that was the ellipse. Okay, now again we come back to the double cone, but we intersecting the double cone for the another plane. Bang. Okay, in this case the angle of the plane is exactly the same, the angle of the cone, and the intersecting figure is this blue curve. Si I remove the plane, I remove the double cone to see, this is my famous parabola. Of course, this is a parabola in 3 dimensions, no? But we study in 2 dimensions, but it's coming from the conic section, no? And this parabola, I'm going to open in one direction, the vertex, we study, but we study in detail now with me in this chapter. Finally, we come back again to the double cone. And now we intersecting with another plane, but this plane have a big angle greater than the angle of the cone, and the intersecting curve look like a green curve. Okay, if you remove the plane and you remove the double cone, you see the famous hyperbola. Hyperbola is again similar to the parabola, but the hyperbola contains 2 branches. Parabola is only one direction. Hyperbola no. Open up, open down, or open right, open left. You see now in the equation we study. I promise this is motivation. Okay, my goal is now that you are exciting to start studying this. Okay. Okay. I come back to the whiteboard. Okay, I share the screen again to the whiteboard. Okay, entonces our goal is to study ellipse, parabola. Let me anticipate something. Ellipse is not circle. Circle is completely round, perfect. We have distance here as a radius always. This is circle. Okay, now ellipse is different. It's like that. Okay, or like that. Okay, depending. No, I call this ellipse horizontal and this ellipse vertical because we have 2 axes. This is a major axis and this is the minor axis. When to say the orientation of the ellipse depending for the major axis. If the major axis is parallel or coincident with the x-axis, it's a horizontal and it's a vertical. And the parabola is similar. The parabola, we can open the parabola, normally the parabola we study at the beginning is like that, open up or open down, and it's a typical vertical parabola. However, we have another parabola that open to the right or to the left. This is a horizontal parabola, and we study in detail the equation for this. Hyperbola contain 2 branches, like that, for example. This is a typical horizontal hyperbola. This axis, there's a new terminology that we study in every conic section, and the ellipse major axis, and the parabola is the axis of symmetry, as you know, but in this case is the transversal axis. Wow, this technical name, transversal axis. A transversal axis coincident with the x-axis or parallel. This is horizontal hyperbola. However, we have another kind of hyperbola like that, in which the transversal axis is vertical. This is vertical hyperbola. Okay, let's go in detail study ellipse first. I like this order. Ellipse first. Let me go to the definition of the ellipses to explain in detail definition of the ellipse. I propose you. Go to Desmos again. Okay, definition of the ellipses. definition of the ellipses. Okay, definition of the ellipses. Let me go to Desmos to understand the ellipsis, where I come from the ellipsis. Okay, this is the ellipsis. Do you see Desmos now? Do you see Desmos now? Aha, okay. Entonces, let me understand definition of the ellipse. After I promise que I present the equation, no? But the definition is the geometric place of the set of the point xy similar to the circle that we studied, but in this case we have important point. Look, what is the definition? Definition is, well, okay, you have different points. You have different points. What point? We have important point. Important point is, look, we have the focus, in plural it's called foci. Okay, this point is negative 4,0 and positive 4,0. This is the foci in plural. It's a focus. Now the focus, the distance to any point on the ellipse, okay, is this point. Okay, you need to change the position, change the component. The sum, look at the distance. Look, I computed the distance 1. The distance 1 is the distance from this focus to this point, and the distance to another distance, no? And you see how this distance change according to the position. However, the sum of the distance is always 10, que es a constant. This is the definition of the ellipse. And by the way, 10 represent the major axis. Okay, the major axis is, look, is the distance from negative 5 to positive 5. This is the interpretation. This is the definition for the ellipse. This is the objective of this script. So I try to summarize the most important point in the ellipse is, look, let me try, segment, importance segment. Well, it's okay. The most important is, let me come back to the whiteboard. You see the animation, nice, I love you, that. And you see the whiteboard now. Okay, I want to erase everything in the whiteboard. Do you see the whiteboard? Look. Okay, this is our ellipse. Suppose. Okay, look like that. Well, let me use another color. I love red color. Suppose. Okay, this is my major axis. In this case is horizontal. This is the major axis. And the endpoint of the major axis is called vertex. In plural, vertex. Okay. And by the way, in the equation of the ellipse, suppose the equation of the ellipse here is similar to the equation of the circle, is x minus h squared plus y minus k squared. But we have no radio because the distance is different. This is a squared and this is b squared and this is equal 1. This is the standard form of the equation of the ellipse. This is a little bit weird because the standard have no radio, have 1 in the right hand side. This is important. It's extremely important. You want to express it, any equation for the ellipse in standard form, you need to manipulate the equation in order to get 1 in the right hand side. Okay, this distance is a, look. This distance is a, que es the, you know, see the blue part is the entire major axis. This distance is a half, of course, is the semi-major axis distance, no? And this point is a point a comma 0. Well, in this case, because I suppose that the center in this example is 0,0. So I'm supposed to make easy this explanation, que h and k is 0, entonces disappear. And my equation look like that. But no. We see a lot of examples that not necessarily is a coincidence. You can write like that, or you can write like that. Ax over a squared is the same, plus y over b squared equal. Okay. Now this distance is a, this distance now in green color is the minor axis is b. This distance is b. This distance is b. And we have another distance. And we have another distance. Let me use another color. This color is good. Que es the fuzzy distance, que is here and here. And this distance is c. Okay, so we have major axis or semi-major axis, minor distance axis. This is the endpoint of the minor axis. Endpoint, in this case, is 0, b, no? And this point is 0, negative b, because I suppose it should be the center is 0, 0, otherwise no. And C is the focal distance. C is the focal. Important. C focal distance. Because we have two focus. Okay? Or foci in plural. Foci in plural. And the distance is, in this point, is the point minus C, 0. In this case, the point is the point C, 0. And the relationship and between A, B, C, I don't want to prove that, is A squared is equal B squared plus C squared. Esa formula. Esa formula. It's the most important formula in the Elixir. Okay, we have another formula in the Elixir. Well, okay. Well, this is, okay, this is the Elixir, okay, but we have another kind, no? Of the Elixir. We have another kind of the Elixir that look like that. Suppose again, to simplify the thing, the center is located in the origin again, okay, no problem. However, this Elixir is different, it's like that. Okay, and this is called vertical, right? Vertical Elixir. And the major axis now is here. It's a major. It's parallel or coincident with the y-axis. This is A now. And this is the vertex, and this is another vertex. And this is the minor axis, and this is the endpoint of the minor axis. And how you recognize that our Elixir is vertical or horizontal? Well, okay, I suppose always that A is the big, look, in the formula you can see that A is greater than B, no? It's obvious, right? It's obvious. Now, when the A is associated with the X, like in this case, I suppose that this is horizontal axis or horizontal. However, we have this possibility, x squared over b squared plus y squared over a squared equal 1. And it's a vertical. This is horizontal ellipse. And it's a vertical ellipse. Okay. Entonces, bueno, how I know que es horizontal or vertical? How do you know que es A or B? Well, depende, no? You suppose que A is the big number. When the big number is associated with the X, it's horizontal. When the big number is associated with the Y, it's vertical. I promise that you see in the example clear this idea, because it's elementary. Okay, one important parameter to finish the theoretical part of the Elixir before start example. es eccentricity. Eccentricity, letter E, is the ratio between C over A. C is the focal distance and A is the semi-major axis. Okay, this ratio give me one intuitive idea how rounded or flat is our elixir. Look. We have different family of the elixir, like that, like that, like that. Okay, and when you have that, the eccentricity is different. The eccentricity give me information how rounded. Suppose a perfect circle. A perfect circle. A perfect circle is obvious. It's obvious que is one particular example of the elixir in which A and B is the same. You see, A and B is the same, it's because C is 0. Si A and B is the same, it's because C is 0. Entonces, eccentricity 0, eccentricity equals 0, represents circle. And we have no focal distance. Eccentricity almost approximately 1 represents completely flat elixir. And the other value intermediate, for example, this is eccentricity 0.8, and this is eccentricity 0.3. Okay? Now I prepare here in Desmos one script to illustrate very well, or I suppose very well, the problem of the eccentricity, no? Okay, let me try to find. Okay, eccentricity, there you go, bam, look at that. Okay, this is my elixir, let me share screen. Okay, let's study in this script now the intuitive idea for the eccentricity. Eccentricity is the parameter that states the relationship. Look, this is A, this is B. Suppose in this case the eccentricity is 0.61. Okay, suppose that I decrease a little bit B. Wow, do you see how the foci, que es the green point, is moving? It's moving away the origin, que es the center in this case, ¿no? Entonces the eccentricity, you see que es 0.93, ¿no? 0.93, wow, 0.93, it's almost 1, 0.98, okay? This is the idea. Suppose now que A and B is the same. Look what happened with the foci. The foci approach, wow, bam! In this case, A and B is the same, and our elixir becomes a circle, and eccentricity is 0. Okay? This is the idea for the eccentricity. Any question? What part is confusing? Okay. Now let's move. Let's move on to example, Professor. Too much theoretical part. I don't like the theoretical part. Now, example 1. Example 1 say we have this equation, x squared over 16 plus y squared over 9 equal 1. Okay, copy that. Let me try to find in Desmos. Okay. Conic section. There you go. Conic section. Okay. U identification. Number 1. Okay, we are working. Do you see the whiteboard now? Yes or no? Let me check it out. Whiteboard is selecting, yeah. Okay, there you go, yes. Okay, U identification clear. Okay, we are talking about elixir. What is the clue? Okay, give me information que es elixir. Not always is obvious. But one clue is the x and y is a square, both, and plus in between. In another conic section, no, don't happen this situation. Y I saw que the big number, que es 16, is associated with x. Entonces, I suppose que we are talking about horizontal helix, because the major axis is associated with the x-axis. Entonces, es obvio compare this equation and the equation that you know is this. It's expressing a standard, nice. A squared is 16, therefore A is 4. You take out square root, but you take the positive value only because we are talking about this time. And likewise, B squared is 9, now B is 3. Okay, now I can see that we have no translation. How do you know that we have no translation? Because when you have translation, you have H and K, suppose. This is the formula for the elixir when you have some translation, one horizontal or vertical shift. In this case, no K, no H. Therefore, the center of our elixir is located at the point 0,0 because H and K do not exist, they're missing. A is 4, B is 3, and I have no idea what about Fuzzy. Well, the vertex, yes, it's clear. The vertex of this elixir is located at the point 4,0 and negative 4,0. So it's on the x-axis, the center. Okay, let me try to make it a roughly sketch. This is my center, 0,0. I know that my elixir look like that. And the vertex is this point and this point. This is 4,0 and negative 4,0 because I discovered that the distance A is 4. 4 in this direction and 4 in this direction. And 3 in this direction and 3 in this direction. So this point is the point 0,3 and this point is 0,-3. Now I need to find the Fuzzy. Okay, the Fuzzy, by the way, I forgot to say, always lie in the major axis. Always, always. We have Fuzzy here. Well, yes, vertical, yes. But si es horizontal, no. And you need to find the C. How you find the C? Well, the formula is for the elixir A squared is equal to B squared plus C squared. Be careful, guys, because this formula is confusing. And the hyperbola, you see similar, but not exactly the same formula. And the hyperbola. Okay, now I have in my hand A and B. I need to solve for C. C squared is equal to A squared minus B squared. Okay. C squared is equal to 16 minus 9. Remember, 16 is A squared, 9 is B squared. Now is 7, no? Is 7. Now C alone is square root 7. Okay, of course, I take the positive value. And to have some geometrical idea, I put in decimal approximation, that's 2.646. And the Fuzzy is located at the point 2,646, 0, and negative 2.646, 0. And by the way, the eccentricity is the ratio between C divided by A, que es radical 7 over A, que es 4, no? And when you compute the decimal approximation, because this is irrational number, it's 0.66. Que that indicate me that the elixir is not too rounded, it's a little bit flat. Not too much, but it's a little bit flat. Okay? So this is important, guys. How many points we need to determine the elixir? We need to find vertex, well, center first. Vertex, endpoint of the minor axis, have no name, it's like that endpoint, and Fuzzy, the component for the Fuzzy. And the eccentricity is just curiosity to understand how flat is our elixir. Okay. That's it, no. This is a roughly sketch, hello, this is ridiculous. Now I need to do in GeoGebra. in GeoGebra, Okay, look at that. In GeoGebra, no, in Desmos. In Desmos, I create one special script. Okay, if you want, I share with you. Okay, look here. Okay, Desmos. Okay, we are talking about example 1. Example 1. Look, example 1 look like that. Bam. This is example 1. Okay, example 1. Okay, this is the I just copy, no? The equation, no? However, I want to see in detail. So I categorization like a horizontal elixir, right? However, I know okay, wow, what happened with the A? A is equal 4, no? Yeah. I don't know why it's no slider here. A is 4. Okay, that's matter. Okay. And B is 3. And H and K are 0. 0, 0, 0. 0, 0, 0. I put it 0 directly here. In my keyboard, I put 0. It's easier to put it directly here. Of the slider. Okay. Now I try to, I categorize like a horizontal elixir. Bang! Double bang. Okay. Now look at that. They are perfect coincidence. Our example. Okay, let me again the movie. Look. Here is I just put the equation. My script put more. Put the equation, the curve, plus the important point. What is the important point? Is the vertex 4,0, negative 4,0. The endpoint for the minor axis is 0,3 and 0,3, and the fuzzy, que es located, remember, in radical 7, 0. Radical 7 is 2.646 approximately, using 3 decimal places. I make a zoom because I like this. Beautiful. Beautiful. You see the segment. I can share with you this script. I send the link and you open, it's yours. And you can maybe improve. Any question in this elementary kindergarten example? Everyone understand very well? Elise? Okay, I promise I want to complicate a lot of this part. Of course. Let's move on to example 2. Example 2 now. Example 2 is 25 x squared plus 9 y squared equal 225. Okay, this is my second example. It's given this equation. I do exactly the same. I determine si es elixir or no. I express in standard form. I determine the center, the vertex, the minor axis endpoint, and the fuzzy. Es obvio que this equation is not expressed in standard, because standard always right hand side must be 1. Right hand side must be 1. Always, if you want to express any conic section in standard, right hand side must be 1. So you divide the entire equation 1 by 1 by 225, because I need 1 in the right hand side. Entonces 225 divided by 25 es 9. So, es 9. 9 in the denominator, no? Because you divide 225 divided by 25, no? Es 9. And likewise, 225 divided by 9 is 25. Plus y squared over 25 equal 1. Oh, much better. Now this is ready to express it in standard. No, actually it's a standard. Okay. Now I immediately discover que our elixir, the major axis lie in the y-axis because a squared is 25, therefore a is 5, and b squared is 9, therefore b is 3. Okay, so our elixir, and by the way, the center again happen is 0,0 because I don't see any translation. H and K are missing. Okay, so our elixir roughly sketch now look like that. Okay, this distance Fi and this distance is 3. Now it's obvious that the vertex of the hour elixir is located at the point, this point, and this point, que es 0,5 and 0,5, no? And the endpoint for the minor axis located entre 0 and minus 3,0. And the foci, well, the foci is located always on the major axis, and the distance, the focal distance is c. Because I need to determine c. Because c is equal, well, the formula is a squared is equal b squared plus c squared. Minus solve for c squared is a squared minus b squared. C squared is equal a squared 25. 25 minus 9 is 16. Now c is 4 because the square root 16 is 4. Okay, so that distance is 4. Therefore, that point is located at the point 0,4, and the other foci is located here, and this distance is the point 0,4, comma negative 4. And we have one approximate idea how to look like. And eccentricity. This is totally optional. Eccentricity is important, but not extremely important. It's the ratio C divided by A, no? And C is 4, and A is 5, A is 4/5. When you convert, in this case, rational, so you convert directly to the decimal, no approximation, the decimal, exactly equivalent answer. At 0.8 is close to 1. That means that our elixir is very, very flat. Okay, it's vertical and very, very flat. Clear or confusing? Okay, but I want to see in decimals. Always. Example, good, very good. This is clear, she said. Yeah, may always help me. Okay, let me go to decimals. Okay, in decimals, okay. Look, we go to example. Okay, let me check it out, see I share the screen with decimals. Oh no. Okay, we are in decimal now? Yes. Okay, example 2 is elixir. Bang. Okay, I just put equation mechanical, directly, no transformation. Decimal is fantastic. Decimal understand very well. However, I want to check and see everything is okay and determine the specific point. So in this case, I discover in the example 2, A is 5. A is 5. And B was 3. It's a coincidence. We are talking about no H, no K. So the center is located in the origin, and we are talking about vertical. Bang, double bang. Look at that. Let me summarize. The vertex located at the point 0,5, 0,-5. The endpoint for the minor axis 3,0, -3,0. Center, of course, 0,0. And the foci is located 0,4 and 0,-4. End the story. Okay, this was example 2. Relatively easy. The only complication was I need to divide by 225 because I need to create right-hand side 1. That's the same thing. Easy, easy, easy. Okay. Let me erase the board. Let's go to the example 3. Example 3 is a little bit more interesting. Example 3. Example 3 is x minus 3 squared over 16 plus y plus 2 squared over 25 equal 1. Wow. In this case, we have the equation of the elixir, yes. Okay, in this case we have translation because I can see h and k. I discovered h is 3 and k is -2. Remember, completely opposite sign, center is located at the point 3,2. Okay, -2, sorry, important. 3, -2. The reason is clear. So you see in the equation. So I compare my equation. In this case, this is b squared, no? And this is a squared. Because I realize that a is 25. A squared is 25, no? A squared is 25. And b squared is 16, no? Therefore, a is 5 and b is 4. Okay. And h and k is the thing I tried to explain. H is +3 because it keeps the same sign. That means when you plug in these 3 here, it doesn't affect the sign. However, here I put positive is opposite sign. Therefore, the k value is, this is h and this is k. It's clear or confusing? Okay. Okay, clear. Okay. Now, okay. I need to determine c. Okay, c, remember c squared is equal to a squared minus b squared. C squared is equal to a squared is 25 minus 16 is 9. Therefore, c is 3. Now the focal distance is c. Now. Bueno, the centricity by curiosity is c divided by a. C is 3. Is 5. And decimal is 0.6. It's flat, but not too much. And this elixir is vertical because a is associated with the y. So our elixir look like that. I can roughly sketch. The center is located at the point 3, -2. Wait a second. Okay. 3, 1, 2, -2. This is the center. Okay. And our elixir open like that. Okay. A distance is 5. A5, no? A5, look. A5. And from this you move 5 over and downward. Say 5 over and we have a -2 plus 5 +3, I suppose. No? 1, 2, 3. Okay, this is one vertex. Okay, by the way, it's the point 33, no? Okay, this point is the point 3 comma negative 2. And 3 down, 1, 2, 3, and negative 5, no? And negative 5, no, negative 5, no. And negative 7, because there's 5 this time, just a 5. Sorry, it's negative 7, look. F5, 5 this time from the center. 1, 2, 3, 4, and 5. Here, negative 7. Entonces es 3, negative 7. Okay, let me summarize here. Vertex is 3, 3, and 3, negative 7. Guys, I don't like to memorize any stupid formula. This part of the mathematics is called analytic geometry, and this is geometric, and you put the figure, right? And also we are doing decimals. You plot the center, you know que the A que es the major axis this time, phi, y I know que the major axis is located in the y direction, entonces you move phi upward and phi downward. Likewise, you want to find the minor axis, entonces to the right and to the left. What distance? 4 distance. I move 4, 1, 2, 3, 4 here, and 1, 2, 3, 4 here. Entonces the endpoints of minor axis is negative 1, 2, negative 2. Here, this is negative 1. Look, this point is negative 1, negative 2. Because the HK component stays the same, with the more horizontal, and you decreasing and increasing. Entonces this would be 7, no? Yeah, 7. Yeah, 7. 7, negative 2, no? Because it's 3 plus 4, 7, and 3 minus 4 is negative 1. Okay, so our list look like that, something like that. Right. Now this is the major axis, okay, and this is the minor axis. I know very well that the fossil lie here on the major. What distance? The distance focal. Focal distance is 3. Then 3 up and 3 down. Oh, no. Entonces no like that. Is 3 up. I suppose that this is negative 2 plus 3 is 1 here. Now the focal distance is 3,1. What is E again? Okay. E is eccentricity, but we compute it after. Is the force is located 3,1, and the other force is 3 down here. Is located at the point 3, negative 5. This is force in green color. And the eccentricity. I did that here. 0.6. And see 0.5. See the eccentricity is less than 0.5. You consider que es a little bit rounded. See it's greater than 5.5. Just flat. Okay, depende si es horizontal o vertical. Okay, just in case you want to see in decimals. Do you understand everything okay or no? Clear? I am doing too fast because the first problem I explained in detail, no? But I suppose that you will improve your knowledge, no? Okay, let's go to the decimals. Now, example number 3. Okay, example number 3. Example number 3, no number 2, number 3. Carajo, number 3. Look at that, number 3. Number 3, I put equation like that, like the region is given. Bang. Okay, elixir. Elixir que you see que es a little bit flat, pero vertical elixir. I discovered que A is 5. Okay. B is 4. I change that. B is 4. H is 3. And K is -2. And you categorize like a vertical elixir, no? Bang. Double bang. Okay, you see in red color the major axis, in green color the minor axis, and the foci lie exactly. This is the vertex, this is the foci, and this is the endpoint of the minor axis. End the story. We are the best in Miami-Dade College. Any question? Any question, guy? Okay. Let's move on to the example 4. It's a little bit more complicated. Why? Because the equation for the elixir is not expressed in standard. No, it's not expressed in standard. Okay, so example 4. Example 4 is example 4. Look at that. Example 4 is 3x squared plus 7y squared plus 6x minus 28y plus 10 equal to 0. Okay, this is expressed in general form. General form is easy to identification because right hand side is 0 always. Everything is moving to the left and organized in descending order of the degree. Quadratic, 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 linear, linear, and constant. Now, you recognize immediately. Okay. Listen to me. This is easy so far because we are studying only elixir. But when you combine everything together, so you need to recognize in the middle of the horrible process, it's elixir because we have x squared, y squared, and plus in between. I don't care the coefficients. The coefficients is not important. See, the coefficient is the same. So actually, this is not elixir, it's a circle. The coefficient is different. So I suppose that we have major axis and minor axis. But the clue is, we have x squared and y squared, nice. And the sign in between is plus. It's minus, it's another thing. Okay, now you realize that you need to complete the square. So be right. Because I need to express in standard. Standard is going to the right hand side 1, no? Okay. So say you grouping the x part like that. 3x squared plus 6x. And you try to complete something here. 7y squared minus 28y, complete something here. And the right hand side, you move -10 and 2 things. This is a little bit complicated. Let me try. So actually, no. I put in blank here. Nothing. Why nothing? Because, you need to factorize. So you find the great common factor. You find the great common factor. The great common factor is obviously 3. And you factor out 3 is x squared plus 2x plus now the box. Okay. Likewise, in the y part, the great common factor is 7. Then you factor out 7, and we have y squared minus 4y plus another box. Okay, by the way, it's not exactly this box and this box. No, because you factor out 7. And now you have minus 10 plus 2 boxes. This is the detail. It's obvious that in the first box you have 1. Because 2 divided by 2, let me copy here, is 1, square 1, no? It's obvious 1. And the second is 4 divided by 2 square is 4. This is 4. It's 4. Okay, it's 4. Actually, when you introduce artificially here 1, 1 to complete the square, we are introducing no 1. You introduce a 3 because this 1 multiplied by 3 is 3. So in order to doesn't affect my equation, I put 3 here. The same when you introduce artificially to complete the square 1, 4. Actually, 4 times 7 is 28. It's 28. Now ready to factorization. This is 3 parentheses x plus 1 squared plus 7 y minus, because the first sign is important sign, 2 squared equal, this is 20, 20, 20, 20, 21, no, 21, because 28 plus 3, 31, minus 10 is 21. I finished, no? Remember, right hand side must be 1, so you divide by 21 both sides, everything by 21. So we have x plus 1 squared over 7 plus y minus 2 squared over 3. 21 divided by 7 is 3 equal 1. Wow, fantastic. And this is the nice equation for the elixir expressed in standard. Now, and you can see everything you need to know. The center of this elixir is located at the point -1, 2. How do you know? Because this is H on the opposite sign, of course, and this is K. And this elixir es obvio que es horizontal because a squared is 7, a is radical 7, and radical 7 is approximately, so when this is rational number, I propose always that you try to express in decimal to have some geometry idea how long. Okay. How do you complete the square from the right hand side? Okay. For the right hand side, Sean, the only thing I did was look. Do you understand the left hand side? Yes, right? You put a 1 here. Actually, this 1 is no 1, it's 3. Because 1 times 3 is 3. That is the reason I put 3 instead of 1. And 4, que I need to complete the square inside the parentheses. Actually, it's not 4, it's 28. Because 4 multiplication by 7 is 28. Got it? Crystal clear or confusing? Clear. Okay. 45. 3 a square is 3. Therefore, B alone is radical 3. And radical 3 in decimal approximation is 1.732. Let me try to find C. Okay, C square is equal a square minus B square is 7 minus 3, no? Okay, 4. Therefore, C is 2. Okay, and the centricity is C over 8, C is 4, C is 2, sorry, and A is radical 7. And the decimal approximation of this is 0.7559. It's a little bit. So basically, we are talking about the horizontal elixir, a little bit flat because the centricity is 0.7. And you say in order to determine the rest, is the endpoint, vertex, blah 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 blah. Let's do it directly in decimals because the number is too weird. It's decimal, horrible. No problem. Let's move on to decimals. Okay, I want to share the screen. Okay. Now we are in decimals now. Okay, this is the example. This is the example. Example 4. This is example 4 I create for you. Look at example 4. I copy in the original way without transformation or anything. Okay, however, I discover okay, A is radical 7. Okay, so radical 7 is a little bit hard. However, I use on the keyboard, I put radical 7 here. Bang. And you see here the decimal approximation. And B is radical 3. Radical 3. Bang. And one more information we need. We need H and K. H is -1. You see, center, yeah. H is -1. K is +2. Positive. Okay. And you categorize this like a horizontal elixir, no? Bang, double bang. And this is my famous point. Guys, I share with you this script. And you verification, well, you can, if you want, compute by hand, no? And verification your answer of the point using this script of the decimals. Okay. Let me try to explain the parabola. It's another coding section. Okay. So we are doing an example now of the parabola. Because it's too much. Parabola now. Maybe next time we continue hyperbola. No? Parabola. Do you see the whiteboard? Now parabola. Parabola. Okay, good. Parabola. Are you familiar? How we see in general now? Definition. Okay, we have two kinds of parabola. You have two kinds of parabola. Okay, we have two kinds of parabola. We have this parabola, out. You have this parabola, right? This parabola, it's a vertical parabola. So what is the formula? What is the equation for the parabola? Vertical parabola is x squared equal y. Entonces en parábola we have no a and b and c, no. We have only one parameter, p. Okay, I want to explain the interpretation of p now in a few seconds. Entonces this is the same for both. What is the only difference? The only difference is when the p is positive, the parabola open up, and when the p is negative, the parabola open down. But we have another kind of parabola, que is this parabola, or in this case, this parabola open to the right, and this open to the left. That was up, down. This is right, left. And the formula is similar. Is y squared is equal to 4px. Okay. 4px. CP is positive, open to the right. CP is negative, open to the left. Makes sense. Everything is clear. One more important information we need to know about parabola. Well, the parabola contains different characteristics and parameters. Look, suppose one parabola can open to the right. Okay, this point is called vertex. You know that. And vertex normally is h, k. Okay, we have another point, important point, super important point, que es the focus. Okay, and the distance between the vertex and the focus, that distance is p. So p is the focal distance. P is the focal distance. And likewise, we have in any parabola, we have directrix. Directrix. What is directrix? Directrix is a line. It's a line. Suppose it's a line. In this case, vertical line, because the supposition was case horizontal. This is horizontal, right? Horizontal parabola. So the horizontal parabola, the directrix is vertical line. Parabola. In this case, suppose it's like that. Bam, bam, bam. In this case, suppose it's like that. Bam, bam, bam. Not necessarily. In this case, like that. Bam, 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 bam. Directrix is a line can never cross the parabola. But the important information is that this distance is always p again. P again. P, no B, P. In the parabola, we have no ABC. We have only one parameter, get P. Okay? Now, one more. We need one more information. Directrix is a line, focus is a point, and the characteristic is the distance is P, the distance is P in both directions. And we have the focal diameter. Focal diameter. Focal diameter is that distance. Look, from the focus, you try to put a vertical segment, and this distance from this point to this point, I'm using green color, is focal diameter. And the focal diameter, the distance, the total focal diameter is 4p. That is a reason in the equation you see 4p. This represents the focal diameter. And the semi-focal diameter, you say this is 2p, 2p. 2p, 2p. This gives me some idea how open this parabola is. Okay, it's wider or narrow parabola, no? Depending on P. P control the focal diameter. Entonces es super important. When you are doing the graph of any parabola, we need the specification. Let me see how many points. Vertex. Super important. Focus. Super important. Directrix. Super important. And the endpoint of the focal diameter. Of the focal diameter. And that's it. Vertex, focus, directrix, is this line, equation. I forgot something important. I forgot the axis of symmetry. Axis of symmetry. Remember, we studied this in the other class. This is the line que es perpendicular to directrix, always. Is the line que split the parabola into equal parts. Axis of symmetry. In this case, it's horizontal line because we are talking about the horizontal parabola. The directrix is vertical line. That's it. This is the theoretical part of the parabola. End the story. Okay, let's doing at least one or two examples. I have no idea of the parabola. Okay, example 1 of the parabola. Example 1. Example 1 of the parabola is x squared equal ay. Okay, what is the question? The question is do the graph and determine everything important in this parabola. Everything, guys. See, I see you do the graph of my face, and it's in my face. You put the eyes, nose, hair, and you forgot the mouth. You don't do the graph of my face. So you omit something, you don't complete the graph. The graph is vertex, focus, directrix, endpoint for the focal diameter, and axial symmetry. Okay? Okay. Okay, in this case, immediately I compare this equation and this equation. Okay, this is for 8y. ay. You compare this and this. All right? Because I realize that we are talking about vertical parabola. And when you compare, it's obvious que for P is A, P is 2. And when the P is positive, this parabola open up. And the vertex is located at the point 0,0. Because in general, when you have translation of the parabola, we have x minus h squared is equal to 4p parenthesis y minus k, no? This is the formula when you have translation. This is the formula without translation. Okay. Entonces 0,0 es the vertex, the focus, the parámetro es p. Okay, entonces the focus, let me try to do roughly sketch of the parabola. 0,0, I know this parabola open to the right because it's, no, up, it's vertical parabola, carajo. Therefore, open in that direction. This is the vertex. And the focus is located here. Right? And the P distance, P is 2. Therefore, the focus is located at the point 0,2. Directrix is a line like that. In this case, a horizontal line, y equals -2. Because it's the same distance. P down, que es negative. The axial symmetry is that line, que es vertical line, x equals 0. It's the axial symmetry. And the endpoint of the focal diameter is here. This is the focal diameter, and the endpoint is this. And this distance is 2p to p in total 4p. And 2p is 4. 2p is 4. Therefore, that point is a point 4,2, and that point is a point -4,2. In total, the focal diameter is 8 units because in between -4 and +4 we have 8 units. This is approximately roughly sketch of the our parabola. Okay? Let me check it in decimals to understand much better this idea. No ellipse anymore. No ellipse anymore. Now let's go to parabola, example 1. Okay, example 1 parabola. Okay. Okay, decimal now. Look. Okay, example 1. We are in decimal, no?
Claudia tiene COVID.
How?
Y Mónica tiene que ir a hacer el CT, ahora viene para acá.
Okay. Okay. This is the parabola of our example, no? Okay. Now, I discover que H and K are 0, 0, and 0. Okay, one more information we have P is 2, P parameter, no H, no K anymore, P is 2, positive 2. We are talking about vertical parabola. Bam, double bam. Okay, we have here, you can see clear, vertex 0,0, focus 0,2, endpoint for the focal diameter 4,2 and negative 4,2. Directrix is the line y equal negative 2, and the axial symmetry is the line, vertical line, x equals 0. Okay, let's do it one more, and that's it. Quickly. Example 2. Okay, example 2. I go to a whiteboard. Let me see, whiteboard. Whiteboard. There you go. Okay. Okay, example 2. It's the last one, I promise. Is y squared is equal to 16x. Okay. Number 1, identification what kind of parabola we have. And it's obvious that we have horizontal, because any horizontal parabola the formula is y squared equal 4px, right? When the x on the y is square es horizontal, when the x is square es vertical. Entonces es obvio que 4p is equal to 16, therefore p is 4. And this parabola open to the right. So we are doing a rough sketch of the our parabola. The center of the vertex, vertex, no center. The parabola have no center, have vertex, is located in 0,0, because we have no translation, we have no h, no k. So in general, we have y minus k squared is equal to 4p x minus h. This is the center, our parabola open to the right, because p is positive. This is my vertex, 0,0. The focus is located here. At what distance? P distance. The focus located 4,0. Directrix is a negative 4 line, vertical line, x equal negative 4. And the axis of symmetry is the horizontal line here, coincident with the x-axis, y0. And the focal diameter is this segment, and the distance is 2p to p, and 2p is 8. A in both directions. This point is the point 4, A, and this point is the point 4, negative A. In total, the distance between negative A and positive A is 16, exactly 4p. Okay. This is a rough sketch for the parabola. Let's see quickly in Desmos. Okay. Okay. This example number, wait a second. Example number 2 of parabola. Here, over there. Over there. Do you see Desmos now? Yes, you see, right? Okay. Now we discover h and k is 0, p is 4, P is 4, E is 4. And we are talking about horizontal parábola. No, no hiperbola, coño. Parábola. Vertical, horizontal. Bang, double bang. Okay, you can see now vertex 0, 0, focus 4,0, endpoint for the focal diameter 4,8, 4,98. Directrix is the vertical line, x equal -4, and axial symmetry is the horizontal line, y equals 0. Wow, too much. What do you think? It's clear, confusing, interesting, complicated? Remember, do you see my face now? Remember, today at midnight, I want to receive your test number 4 on paper. Plus, submit the test number 4 online and the homework, no? And the corresponding homework. Everything is clear, confusing, complicated? Okay, I want to take a break a little bit. Cap Bolívar, stay. Wait for me. Okay? Okay. Car, are you there? Have a nice day. Okay, Car, activate the microphone. Car Bolívar, are you there or no? Car Bolívar, are you there or no?